Climate Change Act, which was enacted in 2008, effectively put the UK onto a trajectory of moving towards a low-carbon economy.
The way we use energy is going to change massively, and with electrification of heating and with electric vehicles, there are going to be far more devices on the electricity network.
The way we're generating electricity is also changing, and we need to find different ways to manage that to ensure security of supply.
Technology has come on leaps and bounds in recent years, particularly in terms of communications, electronics and control. And so we're looking at making the most of these new technologies.
The drive to a low-carbon economy has got lots of people thinking about how can we not build network infrastructure. How can we integrate customers more into the development and operation of the network? So ourselves and all the other participants in the energy sector have started to think about how can we persuade customers to reduce their consumption at times where it's beneficial to us as network operators, and holistically that means that they save money and we save money in the longer term.
In Project Falcon, we are trialling alternative techniques to conventional reinforcement to see whether they're cheaper, more effective, more efficient than conventional reinforcement. Part of the Falcon project is trialling demand response. There are two specific ways we're looking at doing this within the project. One is to ask industrial and commercial customers in the local area for up to 2 hours with a 30-minute notice period to use their generators or their alternative source of supply other than main supply. And as part of taking part in the trials, we give them a financial incentive.
Anglian Water's biggest challenge is a changing climate and ever-increasing demand for energy and water. So when we were invited to join in this innovative project, I was delighted to accept.
The control room in Western Power Distribution will identify a theoretical constraint on our network. We will then phone Anglian Water.
Hello, this is Edith from Western Power Distribution.
And ask them to, within 30 minutes, switch on their alternative generator.
Thank you.
It's the right thing to do, and we hope that it will bring benefits for Anglian Water, but also more widely for the distribution network operators area as they try and manage a more and more constrained network.
The other aspect of the trials is to ask a different set of customers to take part in load reduction. So reduce their electricity usage at a certain time of day for a certain period of time. We're only looking at specific times of day, and the ultimate aim is to reduce peak demand times of day and the winter peak specifically.
Demand response as part of the Thames Valley Vision is a huge part of our project. We're engaging 30 industrial and commercial customers into some load shedding programs where we learn to understand how much people can reduce energy, how flexible they can be, and what impact that has on reducing network constraints.
The technology that we're providing to SSEPD is our Automated Demand Response Solution, or ADR. It's a software-based solution, it's cloud-based, which means it's on a remote server that can be accessed via the internet.
When we first log on, we get to see a list of all the participants that are enrolled onto the program, and then we can look at the various events that we can do. So I simply then hit Add Event on the system. This then brings up a screen whereby I can choose the start and finish time of that event. The customer will get an email, and they've got two options then. If they do nothing, the load shed will happen pretty seamlessly. If they do decide to opt out, maybe they've got a big event on where they need a full function of the building, they can simply log onto the portal and opt out. The load shedding strategies are compiled between our surveyors, which is our partners Honeywell, and the individual customer.
Our engineer, along with the building owner's facility manager or engineering manager, do a survey of the building, look at all the electrical plant devices in that building and identify what can be turned on, off, up, down, putting all that together in a way that won't impact the performance of the building and won't affect the comfort conditions for the people inside it.
I must say they were excellent. The engineers were first class, did a fantastic audit. Even though it's a new building, they thought there was a lot they could do to save us energy. When the project was set up, they did mention that there was an opt-in, opt-out option, but to my knowledge we've never ever had to implement that.
In essence, the CLASS project is all about demand response. It's using the known relationship between voltage and demand. And in simple terms, what that means is if you are able to reduce the voltage slightly, then you can reduce the demand on the network slightly, and vice versa. The idea is if we can provide a demand response from our customers when our system assets are at their peak, we can reduce that peak, which allow more and more customers to connect their low carbon technologies to our network and provide us a window of opportunity to further reinforcement. And what the CLASS project will do is it will move the voltage up or down. Now, reality is that will have very little impact to customers. And the example I would give is that if you dropped the voltage to a kettle by 2%, it will just take 8 seconds longer to boil. But to test that hypothesis, the customers will observe no impact. We are doing some extensive customer trials to be able to show that we can provide this demand response from all our customer base and that there is no customers who observe when we do it. If you can show that you can provide a demand response and what that size is and provide it very quickly, there is the potential to be able to get customers to provide a demand response to the system operator. Rather than the system operator, that's National Grid, purchasing very expensive ancillary services, there is the potential that they could be going directly to customers to provide those services for them, which would mean in the longer term a much cheaper balancing set of services for National Grid.